Hello and welcome. Today we're going to be discussing barrier island evolution. So through this presentation today, I'm going to be going over with you three main theories for how barrier islands form, and then the factors that are going to contribute to how fast barrier islands are going to form. So let's get started. So, the three theories then that scientists have on how these barrier islands are going to form. The first one is going to be from upbuilding of submerged sandbars. So, you may have gone to, let's say, a Jersey or Delaware beach, and what you will notice from time to time are there are those sandbars that form out in the ocean. So, you might swim out a little bit and it's a deep area, but then it gets shallower as you continue to go further out into the ocean. So that what you're sending on is a sandbar. So that's one of the theories. The second one is the mainland beach ridge submergence. So here you might have an area of land and then it might be overtaken by water, which then separates it from the mainland. And the third is the spit growth and later segmentation by an inlet. So in this case, we'll go over how that spit might form, and then, as the name suggests, as the theory suggests, it would then become separated from that mainland. So for the first one here, the diagram for the submerged sandbar. So you're out there, let's say this is Wildwood, it's a beach I like to go to, hopefully we'll be able to go to that this summer at some point, and you swim out, and what you would notice is it's deep, but then it gets more shallow as you keep moving out. So this sandbar then does have a potential that it could continue to accumulate more sand on it, and as that sand continues to accumulate, it then will emerge from the ocean itself. And then, if it is emerged for long enough, it could then go through the evolution to become a barrier island. That barrier island then could form these sustaining plants, again, if it's long enough. And those plants could help support the dune, which then is going to help support the rest of this barrier island. Okay, so one theory for how that would happen. The second one, then, the mainland ridge submergence. Here you have a main area of land, and then as sea level rises, there might be potential for more devastating storms that could then allow for lots of wave energy to accumulate on the backside of this dune. And then as time progresses, you can then have this barrier island form as a result of this portion that is going to be submerged from a tidal event. And then the third one is the spit growth and later segmentation of an inlet. So there is a longshore current that is going to form this spit growth. So as you have these prevailing winds, they are going to bring with them energy that's going to take a little bit of sand from this area. And then because of gravity, it is going to bring it back out and move it on until you have the end of that island or the end of that landmass, and it's going to form this little spit. And as it continues to accumulate sand on it, it will then have the potential to become overtaken by maybe an inlet or maybe some type of storm that cuts this from the mainland. And then you have your barrier island that can form as a result of that spit growth. So the factors then that are going to influence the rate at which a barrier island will form. Well, the first one is going to be the rate at which sea level is rising. So, as we know, global warming is happening, and as global warming is happening, it is releasing more fresh water that's trapped in glaciers into the ocean environment. And that is gradually, slowly over time, increasing the sea level. And as the sea level is going to increase, it is then going to allow for this mainland to become fragmented and have that separation forming barrier islands. Second is the sand supply. So with this, if there is more or less sand supply, it's going to control the rate at which spit growths are going to form, and that then is going to influence how quickly barrier islands will form. The sea's energy will also influence this. So if you'd say more turbulent sea, then it's going to be a much more dynamic system. It's going to be changing much more quickly than if the sea was a calm sea. And then this one, maybe more so compared to the rest of them, would just be human intervention. What are we doing that's going to actually contribute to all three of these? With our human nature and our overuse of things, we are definitely contributing to a much more rapid sea level rise. We all like our property and want to keep it, so we actually do contribute to sand supply. We do not allow for a lot of natural factors to happen that would might keep it at a more constant rate, but instead we are going to try to hang on to that and then alter those geological processes. And sea energy. So, if we think again about global warming, the warmer that systems are, the more that they move, they're just going to have more potential energy. So, therefore, the sea energy could be contributed then to our intervention and what we are doing to our planet. So, if you remember earlier in this unit, we went over the different oceans. If we think of the Atlantic Ocean, remember, is going to be pretty broad and plain, and it's not going to have a lot of those fluctuating caverns like the Pacific Ocean is going to have. So, because it's kind of this sweeping, gentle plain on the Atlantic shoreboard, we're going to find a lot more barrier islands there. So, because of that very sloping area, especially in the Atlantic Ocean, but you can find these anywhere. A small rise in sea level is going to be very noticeable, much more in the Atlantic Ocean than it is in the Pacific Ocean. But again, although you can find barrier islands in all systems, you're going to find them much more so along the Atlantic Ocean. And we can really contribute then the sea level rise to our last ice age. So the melting then of the glaciers from the ice age about 15,000 years ago is going to allow for a lot of that barrier islands that we have to have formed from that slow release of water into our ocean system. So as that water moved in, the rivers are going to flood, sediments are going to move from the ocean side of that barrier island to the bay side, and that's going to cause a retreat, an inland, the island to retreat towards the inland. So the barrier islands are always in motion, but they are going to be moving towards the main land. In the Atlantic coasts, our sea level rises approximately 1 foot a century. But then, if we correlate that to the barrier island retreat, barrier islands are very much in motion. They are always moving. So they're approximately moving 100 to 1,000 feet per century towards the mainland. The sand supply then is going to be affected by a longshore current. This longshore current is going to be affected by a prevailing wind. So what happens is as that prevailing wind is going to cause wave dynamics, usually in one direction. And along the Atlantic shoreboard, it's going to kind of go southwest. It is going to cause this formation of what we call swash. Swash is when the water is going to move up. If we think wave energy, it brings with it some sand. If you have ever stood like in the Atlantic Ocean, Jersey Shore, and allowed for waves to move up and just stay in one spot, you'll notice that your feet become covered. Your feet become covered because of that swash that moves up. But the swash doesn't stay there. As the wave retreats, and due to gravity, it's going to bring back with it what we call backwash. and then it's going to allow for this sand to accumulate in the ocean, and that is going to cause that sand supply to move along, and we call that the littoral drift. So the littoral drift is a sand movement along the beach that is influenced from that longshore current. Now, what does happen is that this only really affects just this area here of the barrier island. So this is going to help to kind of direct that energy onward along the side of that barrier island, and it does help to protect the back of the island. But what does happen is if you do stop the sand supply from the littoral drift from this longshore current, then it is going to affect much more so the front of the island. And if the front of the island is not healthy and not resustaining itself, then the back of the island is at risk. Sea energy, what will happen here is if it's a very active sea, so if it's storms moving through, hurricanes, then they can break through the inlets of the area of the barrier island, and they can allow for overwash. The overwash then is going to deposit sediments from the sea, so lots of salty sediments here, into the back of the island. And if it's severe enough, those grasses, the plants, the animals that do not have adaptations for the ocean water are going to not survive. They will also then could bring with it energy that would knock the dunes out. And if you do not have the organisms that can sustain the island, if you do not have the dunes to protect the back of the island, then it can destabilize that island. For these barrier islands, they are going to have a source of connection from the ocean environment, and they're going to be these inlets that will allow for some water to move through. But as the barrier island is going to form, as it goes through this evolution process, these inlets are going to become smaller, and they're going to allow for certain areas on the backside of the island to have a blockage from the ocean water moving in. And once those areas are blocked off, then you can form marshes. Marshes are going to be formed on the back end of the island, opposite of the ocean. And the marsh ecosystem is something that is very valuable for a lot of the organisms that live on the barrier islands. It's where they're going to allow for their reproductive portion of their life cycle to take place. So they are very important as well in the ecology of the barrier island. And then lastly, our human intervention. So I don't know if you've ever been to Ocean City, but if you've been to Ocean City, or if you can look at this picture here, you can see that it is highly developed. So Ocean City plowed down a lot of the dunes that were here to build these high-rise hotel buildings. But dunes are going to allow for this island to much more readily withstand a lot of those environmental impacts, especially from wave and storm energy. Dunes can take a lot of brunt force and will just really dampen then the energy that moves to the back. Without them, wave energy then causes lots of overwash on this barrier island, and it's going to be causing sand to not just deposit right along the shoreline here, but it's going to deposit some sand on the back of the island. And this is just going to speed up that process at which this barrier island is retreating towards the mainland. Dredging is also a cause of human interference. So if we have those storms that come in and we don't have the dunes in place to buffer, then a lot of the sand is going to leave as a result of that littoral drift, the longshore current. And so then you're going to need to dig up sand from other places to be able to put it back to provide that beachfront property again. As a result, if you are digging up sand from out here in the ocean, it's going to, again, make it so that it's going to have an increase of wave energy. You're not going to have that kind of slow roll. You're going to have much more variable dynamic waves that can bring with it a lot more potential to destroy the barrier island. Here's a classical example. So in 1960s, European settlers first made their way here to the Cape Cod region, which is a barrier island. What they did, though, is they removed a lot of this vegetation then that would support dunes. So dunes, you might think of, they look just very much like piles of sand. But what you don't see is all of the root systems in the dunes that hold that dune together. And if you do not have the plants here, and if you have removed them, then you cannot have functioning dunes, and therefore that's going to prevent those dunes from acting like a buffer of the wave energy, and it's going to bury these maritime forests that would be here. It's going to destroy all of the timber that they would have needed, or a lot of the timber that they would need. It's going to destroy the ponds, the freshwater ponds on the back of the island, and even bogs that would be sustainable for different types of farming practices, as well as just organism diversity. So humans, absolutely a major cause in the evolution of barrier islands. So in summary, first, barrier islands are going to be along and more commonly the Atlantic coasts, and they're going to continue to retreat towards the coastline, so southwest. If the sea level is going to continue to rise, then this is going to take place much more quickly. And the last one, just keep in mind that barrier islands are moving islands. So they are moving towards that mainland. And a lot of the barrier islands that we have are right along the Atlantic coast where we are very close to. So without making sure then that we can slow down the sand supply, our human impact, wave energy, then we are not going to be able to have these barrier islands for as long as they should be around. And that can lead to some devastating things. I wanted to just show you this picture here. These are called groins. These groins, as you can kind of see, are going to trap that sand so that this beach or this beach is going to be able to sustain itself. So these residents here will have access to the beach. But if you are down here and there is not a groin in your area, then you are going to have much more sand depletion than as would normally happen. So that's one way humans are trying to hang on to the sand that they have in their area. Again, maybe not really realizing that these barrier islands are dynamic, that they are always moving and that they're not going to stay the same way for their existence. So here is Assateague Island and Ocean City right next to one another. I thought this was interesting of a historical perspective. You can see that it has moved. So here you have 1980, the coastline here, and that it has, this is 1980, this is 1849, that within a matter of 130 years, this island, you can see, has retreated. Ocean City has not retreated as much, but again, Ocean City is going to be putting in these seawalls and these groins that are going to prevent it from losing a lot of its land due to sand loss. But if you notice right after that, this Assateague Island, it is being much more severely impacted. It is not, it was retreating much faster because all of the sand is being stopped right here. And then one other way, and this is the last way that humans interfere, is they build seawalls. So this might protect your land for longer, but what you notice is you don't then have the diverse ecosystem. You don't have your sand sediment that has the dune system that does help prevent a lot of that wave energy. So it's just a matter of time then in this area where wave energy will eventually overtake the island. Well, I hope you learned something, and hopefully you can fill in the notes as you had them in your Google Doc. And as always, if you have any questions, please let me know.